Hello, my name is Chi Li, an assistant professor at the National Jiaotong University. The paper I will be presenting today is titled Ghost Calls from Operational 4G Call Systems, IMS Vulnerability, DoS Attack, and Countermeasure. For most of the time, many people's phones do not have any incoming call, sign, or ringtone from cellular voice service. It means no one is calling you. Is this always the case? Maybe not. Probably you are under attack. Without discovered vulnerabilities, an attacker may make ghost calls to your phone so that your call resource is occupied. Then no one can reach you. Certainly, to launch the attacker just needs your phone number, and during the attack, there are not any signs on your phone. Different from the former voice services, all the major operations of VoWiFi, which is one 4G voice service over Wi-Fi, are done by the software. So it has larger attack surface. For example, once mobile OS is compromised, the VoWiFi traffic can be intercepted, analyzed, and even fabricated. 4G voice services are supported by a system called IMS. For the voice services, the call operations relies on SIP for call signaling and RTP for voice delivery. There are two kinds of 4G voice services. One is VoLTE. Its UE connects to the IMS through LTE base station. The other is VoWiFi. The connection goes through Wi-Fi AP and Internet. Here you can see VoWiFi traffic needs to traverse the public domain, so it requires higher level security protection. To protect the VoWiFi traffic, an IPsec tunnel is built between UE's Wi-Fi interface and the security gateway in the 4G core. The other IPsec section for specific application, VoWiFi here, is built between the UE's virtual interface and the IMS with the transport mode. However, they can be hacked. VoWiFi synchronization can be hijacked. It allows an attacker to manipulate IMS call service operation. If IMS has any vulnerabilities which were hidden by the former voice solutions, they can be exposed to attackers now. Overall, we discovered three security vulnerabilities. VoWiFi synchronization can be hijacked due to the first vulnerability. Based on the session hijacking, the attacker can interact with IMS on a per message basis. We then discovered the second vulnerability that concurrent call attempts are allowed, and the third vulnerability that the callee may get stuck in the call state machine. These vulnerabilities have been validated in 2 Asia and 2 US carriers using 15 phone models with 7 phone brands. By exploiting the vulnerability, we can develop a stealthy call DoS attack. The DoS attack caused by a call attempt can be considered as a building block. The attacker can keep generating call attempts to make victims suffer from long-term denial of service attack. In this attack model, the attacker just requires commodity smartphone and the victim's phone number, but the victim has to be using 4G call services. For the impact on the victims, the attack can cause up to 99% DoS time without user awareness. However, the DoS attack can work for only idle 4G users with the same carrier as the attacker. When target users temporarily hand over to 3G or are with another different carrier, the attack fails. The next question is, can we detect attackable phones remotely and silently? The answer is yes. We can infer remote phone status based on the initial SIP messages. The major idea is that the SIP message content, flow, interval may vary with different phone statuses because their call attempts may be processed by different new entities and procedures. By applying machine learning to status categorization, each silent attack call can also detect the victim's full status. All proposed solutions have been evaluated on our prototype using Open IMS Core. These vulnerabilities call for immediate attention from global carriers, device vendors, and the standard community. Moreover, we have been working with GSMA to address them. Thanks for your attention.